Welcome back, everybody, to Daily Maths Concepts. What we're looking at today is a circle theorem question. So let us go for it. Let's go. In the diagram below, ECG and F are points on the circumference of a circle. EG is a diameter of the circle, and the tangent AEB is parallel to CD. Angle AEC equals 68 and angle EFD is 106. All right, so we're looking at the diagram. The first question reads, it says, determine the value of each of the following angles. Show detailed working where necessary and give a reason to support your answer. All right, they did say give a reason, right? Not the reason. So based on what we'll be doing, we'll be picking just one reason to back up our answer. So let us go. First one, it says we want to calculate the angle ECD. When what we want to do is to always highlight the angle. So it's ECD. So we're going to mark the angle ECD, ECD. All right, so ECD is this angle right here. It's always good to mark the angle when you're going forward, right? Now, we want to find that angle. If we look carefully, right? So this is the angle right here. But if you look carefully, you will realize that we do have a parallel line running there where, remember that CD, it is parallel to AB. And because of this, then CE becomes a transversal. This idea that we're going to be using is not a circle theorem idea. It is just a regular geometry idea where alternate angles are equal. And some of us may call it Z angles, right? So that angle 68 is the same as the angle that they're asking us for. This angle here is 68 as well. Alternate angles are equal. So for me, I'll put 68 degrees and I'll put alternate angles are equal. And we're definitely referring to when they're between parallel lines. All right, next question says CEG. CEG. We want to mark that angle CEG. CEG. CEG is this angle here. Now, one of the good things that we're noticing here, and I will highlight it, is the fact that CE is a diameter. AB or AEB is a tangent. And so two radii would make one diameter. The rule that says when a radius meets a tangent at the point of contact is 90 degrees will apply here. So this angle here is 90 degrees. And because that is 90 degrees, and I do have 68 degrees out of it, I could simply say, well, if I want to find CEG, then it's going to be the 90 degrees, and I want to take out that 68, right? So 90, you take away that 68, you're left with about 22 degrees. And this angle right here is 22 degrees, right there, CEG. And the reason I would use is I would say radius meets tangent at 90 degrees. So the next question says, let us find CGF. CGF. Let's mark that angle. CGF. All right, CGF. CGF. All of this angle here. Okay. So what we're going to do, though, is that we're going to be utilizing the cyclic quad. And the cyclic quad is at CGFE. So we're definitely seeing the cyclic quad there, right? And what we want to do is remembering that the opposite angles in a cyclic quad, they do add to give 180 degrees. So it simply means if I can find this angle on this side here, if I could find this angle right here in this little corner, if I can find this angle right here, right now, right? I will now add that angle to, if I could find that angle and add it to 22, we could take that from 180 and it's going to give us this. So that is our intention, right? Now, what we want to do though is to find this angle, but we have a nice clue here to help us. Remember again, that radius meet tangent at 90. So all of this angle here is 90 degrees. However, this piece on the outside here, we could quickly find that by utilizing what we call co-interior angles. Now, co-interior angles, they do add to give out 180 degrees, which means this 106, and this angle, they are co-interior since these two lines are parallel. So let me highlight those parallel lines for us one more time. Remember, this, that, and then this is the transversal this side, right? So we're seeing the parallel lines, and then it means that this angle here is co-interior with that angle down there. So we're going to be utilizing that to help us to sort that out right about now. All right. So let us find that. Now, all we're going to do is to say 180 degrees minus 106. And it's going to leave us with about 74 degrees, right? 180 minus the 106 will make this angle here 74 degrees. And that's 74 out of the 90, right? Remember that if we subtract that 74 from the 90, we're going to get 16. So this angle here is 16. Now that I know that that is 16, then all of this is going to be a combination of what? 16 plus 22, and this is 38 degrees. Opposite angles in a cyclic quad, they do add to give 180. So CGF, that angle, is going to be 180 minus 38, right? And when we do so, then we're getting 142 degrees. This is 142 degrees. And there are a number of things that we used, right? So I'm just going to finalize and say opposite angles in a cyclic quadrilateral adds to 180 degrees. All right, so there it is, a nice circle theorem question. I trust that you understood. Please like, subscribe, and share this. See you next time. Bye-bye.